So today we will continue with division of radicals, but exactly the topic when we have different index on the radicals. It's going to be very similar of multiplication of radicals with different index because the first thing we need to do is we need to convert our radicals in order to have the same index. We need to look for a common index between the ones that we have, and after that it will be a normal division of radicals. So in this case, the first step we need to do is, remember, we need to transform our radicals in order to have the same index. So first of all, remember, we can decompose the numbers. In this case, the 18 is going to be 2 that multiplies 3 squared x cubed y to the 4 c to the 5. And the other one, of course, we cannot like decompose it. 3x squared y squared c. What happens next? We need to look for the common index. In this case, we need to use the least common multiple between the indexes 6 and 4. So it's going to be divided by 2, it's 3 and 2, divided by 2, it's 1 and 3, divided by 3, it's 1. That means it's going to be 12. So that means we need to transform our radicals in order to have the index 12. So what happens here? 6 multiplied by 2 becomes 12. That means whatever it's inside the root must be squared. So it's going to be 2 squared that multiplies 3 to the 4, that multiplies x to the 6, y to the 8, and c to the 10. Remember, when we have a power of a power, in this case the square of a power, we need to multiply them. So in the other one, it's going to be 4 to become 12. I need to multiply it by 3. So we need 2 cubed every term inside the root. So it's going to be 3 cubed. Then it's going to be x to the 6. Y it's going to be to the 6 also, and c to the 3. So what happens here? We can put it on a single one, 12, and it's going to be on top. I have 2 squared that multiplies 3 to the 4, x to the 6, y to the 8, and c to the 10. On the denominator, we will have 3 cubed, x to the 6, y to the 6, c to the 3. So in this case, what we need to do next is this x to the 6 with this x to the 6. So it's going to be the 12th root of 2 squared, 3 to the 4 and 3 cubed. It's going to be only 3 on top. Y to the 6 and y to the 8. It's going to be only y squared. And c to the 10 and c to the 3, it's going to be c to the 7 on top. We have a 1 on the bottom. That means we will have the 12 root of 4 times 3, it's 12, y squared, c to the 7. Of course, we cannot take it out from the root because we will need a power 12. All of my powers are smaller than 12. So this is going to be the final answer. So as I was telling you, the idea is very simple. The only extra step from a division of radicals with the same index is that we need to convert our radicals in order to have the same index with the same process that we used to do when we have a multiplication of radicals with different index. So let's see another example. So let's see. In this example, the first thing we can do is that we can decompose the numbers that are inside the roots. So this one is the square root of 2x. We cannot decompose it. But the other one is going to be the cubic root of 2 squared x squared. Then we need to look for the least common multiple between the index. In this case, we have index 2 and index 3. So of course, it's going to be 6. So we need to convert our radicals into the 6th root. So what happens here? 2 to become 6 gets multiplied by 3. Of course, the coefficient doesn't change because it's outside the root. What happens here? We multiply by 3, so the one that it's inside must be cubed. So it's going to be 2 cubed x cubed. What happens with the other one? The coefficient doesn't move. 3 to become 6 gets multiplied by 2. That means whatever it's inside must be squared. So it's going to be 2 to the 4 x to the 4. What happens next? Of course, it's going to be a division between the coefficients. So if I divide minus 1 over 5 divided by 2 over 15, remember we can flip this one. So it's going to be minus 1 over 5. That multiplies, if we decompose the 15, it's going to be 3 times 5. This 5 with this 5, so it's going to be only minus 3 halves. So it's going to be minus 3 halves. We can put both radicals into the same one. On top we will have 2 cubed x cubed, and on the bottom we will have 2 to the 4 x to the 4. So what will happen next? Minus 3 halves the 6th root of 1 on top, 2 to the 4 and 2 cubed, it's going to be only 2, x cubed, and x to the 4 is going to be only x. Of course, it's not possible to take out anything from the root, so this is going to be the final answer. So as I was telling on the other exercise, the only thing we need to do is we need to transform our radicals in order to have a common index, and after that it will be a normal division of radicals. So let's see one last example. So let's see here. First, we need to decompose whatever it's inside the radicals. So here's going to be 4. The 32, if we decompose the 32, 2 is 16, divided by 2 it's 8, divided by 2 it's 4, divided by 2 it's 2, divided by 2 it's 1. So it's going to be 2 to the 5, 8 to the 7, divided by, here we have an odd root of a negative one, so we can take out that minus sign since the beginning. The cubic root of 2a. What happens next? We need to look for the least common multiple between 4 and 3, the index. Divided by 2 it's 2, divided by 2 it's 1, divided by 3 it's 1. So it's going to be 12. So we need to transform our radicals into the 12th root. Of course, this one will still be a negative one. So it's going to be 4. To become 12, I need to multiply it by 3. That means whatever it's inside, we need to cube them. So here it's going to be 2, 5 cubed. It's going to be the power 5 to the power 3. It's going to be 5 times 3, that is 15. A is going to be 7 times 3, it's going to be 21. The other one, of course, 3 to become 12 gets multiplied by 4, so we need to power it by 4, so it's going to be 2 to the 4, 8 to the 4. What happens next? We can put them on a single one. The 12 root of, and let's see, on top is going to be 2 to the 15, 8 to the 21. On the bottom, it's going to be 2 to the 4, and it's going to be a to the 4. So what will happen here? It's going to be minus, and we will have the 12th root of 2 to the 11, a to the 17. The bottom is a 1, so it's going to be minus the 12th root of 2 to the 11, a to the 17. So of course it's possible to take out an a, because 17 is bigger than 12. It's going to still be a negative 1, minus a, the square root of 12, or the 12th root of 2 to the 11. Remember, 17 divided by 12 is 1, and the remainder is 5. So 5 of them will be still inside the root. So this one can be an answer. Of course, somebody can say 2 to the 11 and put that answer. And put something like 2048, 8 to the 5. Both answers will be correct. So that will be it for division of radicals with different index. So the idea is basically only to transform them in order to have the same index. After that, it will be a normal division of radicals with the same index. So we will see each other on the next video.